All right, now we're going to do reference angles. There's a big definition here which we'll look at, but I just want you to remember reference angles as bow ties. Bow ties. They are the pink, blue, and white triangles that you created on the day we made the unit circle. So my unit circle is getting pretty warm right now. But these angles are reference angles. White one. Reference angles, it's the angle that the white set are 30-degree angles. 30-degree angles in every quadrant that the vector makes, that the angle makes with the x-axis. It's all about, okay? So the white are your 30-degree reference angles, the blue are your 45-degree reference angles. Excuse me, the pink are your 45-degree or 60-degree reference angles. The blue triangles make a 60-degree angle with the horizontal. And what we've seen with our unit circle is that all the blue functions, right? All of the cosines are 1/2. All of the sines are radical 3/2. All of the tangents are 3. Now the sines change right across the street being the y-axis. This is -1 in the second quadrant. It goes negative. The sine is positive, and the tangent is negative because we're dividing a y divided by an x. So the sines, but for all of the blue reference angles, the values of those angles are the same for all 4 reference angles. So we're going to explore that in a teeny more depth today. So first we're going to draw a 60-degree angle in every quadrant. There's the 60-degree angle in the first quadrant. There's the 60-degree angle in the second quadrant. And when I say 60 degrees, what I mean is it makes a 60-degree angle with the horizontal. 60 degrees with the horizontal. This is quadrant 1. This is quadrant 2. Okay? This is quadrant 3 is right here, and it makes a 60-degree angle with the horizontal. And then in the fourth quadrant, this makes an angle with the horizontal. So notice the unifying factor. You put an arrow into every quadrant, and what angle does it make with the horizontal? If this is a 60-degree reference angle, then it's a 60-degree angle with the x-axis. Okay? Now, I see quite clearly that this is 60 degrees. What is the measure of this reference angle in the second quadrant? Well, it's 60 degrees on this, but really we measure an angle 0, right? So if I want to know what the entire angle is, the actual angle, the measure, I would say for the second quadrant, quadrant 2, let's call the 60 degrees we call theta prime, meaning it's the reference angle. We make it in every quadrant. But what is the actual angle? So let's write this. Theta is the actual rotation angle. Okay? And here in the second quadrant, the answer will be 180 minus theta prime. Minus 60 will be 120 degrees. In the third quadrant, what happens here? I start from 0, I go, and what have I done? This is 60 degrees, we know that, but the entire amount of rotation, quadrant 3, is 80 plus theta prime. 180 plus 60 degrees is 204. And in the fourth quadrant, I start at 0, I go all the way. How do I get that much rotation? I take 360, right? And I subtract theta prime, which so this would be 360 minus 60 is 300 degrees. So what we in quadrant 1, theta equals theta prime, right? It's just 60 degrees. It's that much rotation. Quadrant 2, 180 minus theta prime, 180 plus theta prime. Quadrant 4, 360 minus theta prime. And what is that what's happening here is we're making what happens when all of these angles, they're all the same, right? A bow tie. And so this is 60, 60, 60. Actual measure of these angles are 60, 120, 140 because it's all, and and 300 is this angle. Okay, so those are reference angles. Let's look out here and say, find the ref for 120. We already know that, we just did it, but let's, just for practice, draw an angle approximately 120 degrees. We want to know what is the reference angle. So what I do is I say, okay, I know that that is 120 degrees. I need to know what theta prime is, or the reference angle. So what I do, I'm in quadrant 2, so I take 180 minus 120, and that will give me the reference angle of 60 degrees. Let's draw this. I am negative 135. What does negative mean? It means go the other direction. So I go the other direction past 90, 135 is right here. And these are equal 45 degrees. So this is 45 degrees, this is 45 degrees. So what is my reference angle? Okay, in this case, what I would do, I want to know what this angle is, the angle that I make with the horizontal, and I can see that it's 45. Theta prime equals 45. I'm trying to find out for reference angles, what angle do I make with the horizontal? So I've got the horizontal, I'm going to just be all about the horizontal. So what did I do here? This was 60 degrees with the horizontal. This is 45 with the horizontal, 208 degrees. So I'm going to go around into the third quadrant. I'm not really sure what that is, right? So I have to say, well, what I do is I take 280 and 180, and I say 208 minus 180. Well, 208 minus this 180 will give me my reference angle. So 10 minus 8 is 2, 28 degrees. So this angle right here is 28 degrees. And if I add 180 and 28, I'll get 208. Negative 292. I know that's that if I were going positively, I'd be in the fourth quadrant. Negatively, so I go around. I know I'm going to be in here somewhere, right? Somewhere in the first quadrant. Say to myself, I want to know what this reference angle is. What angle am I making with the horizontal? So what I do is I take 360 degrees and I subtract 202. And I get 15 minus 6. There I got 68 degrees. And so this angle, the horizontal, is 68 degrees. So these are the theta primes, 68, 28, 45, 60. All right, flip the page. What I want you to do, we'll do one together and you guys do the rest before you come into class. We know theta prime is 25 degrees, so draw it in quadrant. There we go. First quadrant. Theta prime equals 25 degrees. But what I know is what are all the reference angle measures. You can do is you can draw just these bow ties, right? These bow ties. Draw our bow ties. And we want 25 degrees with the horizontal in every, so make sure you highlight your horizontal. We know that each of these little angles measures 25, 25, 25. What I want to know, what is the actual rotation? So for quadrant 2, what did I do? 180 minus 25 theta prime equals, calculator, and just say 180 minus 25 equals 155. So in the second, 155. In the third quadrant, I say 180 plus 25 be 205. Okay, that's in the second quadrant. That's the reference angle in the second quadrant. Degrees. And what about the fourth? 360, and I want it all the way around. So I take minus 25. It's going to be 335 degrees. Okay? And so that's what we're looking for. What are the measures of all four reference angles for a 25 degree theta prime? So go ahead and do 6, 7, and 8 for class. All right, we'll just, you can stop the tape and finish those. And then let's do this kind of problem. Given that theta prime is 30 degrees, so in any quadrant, our theta prime is 30 degrees, find the coordinates of the points on the unit circle corresponding to quadrant 2, quadrant 3, and quadrant 4. So you're going to do bow ties again. That's similar. What are the angles? And you're just making bow ties. And you're finding, now we're finding the coordinates. We did not find that before. So this is 30, 30, 30, 30. Well, I know this is on the unit circle, right? So if this is 30 degrees, then the coordinates are long side, radical 3 over 2, short side, 1/2. That will be quadrant 1. The coordinates, the whole point about reference angles is that these values are going to be the same. They're going to be radical 3 over 2, 1/2 in quadrant 2. But what changes? What changes is in quadrant 2, my x value, I'm going negative for x. So the cosine value will be negative, but the sine value will be positive. In quadrant 3, the values will be the same, radical 3 over 2, 1/2, but they will both be negative because we're going negative, 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 negative. And in quadrant 4, what happens? Same, radical 3 over 2, 1/2. The cosine value is positive, but the sine value is negative. Okay, so all the actual values are the same. Remember, this is 0.866 and this is 0.5. The values are the same, the signs are different. Now, let's look at this. Same kind of problem. The sine of 18 degrees, so let's draw 18 degrees. 18 degrees, there's a point, 18 degrees. What it said is that the sine of 18 degrees is 0.309. You know that that's the y value, 0.309. And the cosine 951. Now, evaluate the sine and the cosine of 162, 198, and 342. Well, if these are all reference angles for 18 degrees, and we'll check it, then these values will be the same and the signs will be different. So this is quadrant 1. So let's just double check. If I want quadrant 2, I double check and I say, what is 180 minus theta prime, which is 18? And I get 162. Oh, quadrant 2. So my values are the same, 0.951, but that's negative because of the cosine value, 0.309. In an angle, second quadrant is negative, positive, negative, positive. Okay, a value into the third quadrant is negative, 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 negative. For quadrant 3, it will be negative 0.951 and negative 0.309. Quadrant 4, I have to go in, if I want to make an angle in the fourth quadrant, they're all positive, negative. So it'll be 0.951, negative 0.309. Okay? So that we've learned about reference angles. Please finish up any blank problems before you come to class.